Okay, starting lesson 24, solving systems of equations using the elimination method. So this is just another method that you guys can use to solve systems of linear equations. Now, you need to know that this right here is the same chart you've been seeing, the same chart I've recreated for you 5 or 6 times. Okay, if two lines are parallel and not on top of each other, okay, as in they have the same slope but different intercepts, then they are inconsistent. They do not have an answer. There's no solution for that problem. On an independent system, meaning they have different slopes, they will only cross once. And on a dependent system, everything is the exact same. The slope is the same, the intercept's the same, and the lines are on top of each other. So that's infinitely many solutions. Reminder, no solution, one solution, infinitely many. That's the only ways you can go. Okay, any questions there? Should not. Okay, elimination will basically get rid of one variable for you at a time, and then you'll be able to solve for the other one. We start this with 2 variable equations, but we're going to build up to 3 variable equations. So make sure that you know what we're doing as we're doing it. Ask questions as needed. Example 1 gives us 2 equations. It has 15 equals 3x minus 2y. And I set these up in 2 columns, so just like I was doing with substitution, so that I can work them next to each other. Okay. Now this one, the way it's set up, if we weren't solving with elimination, this would be really easy to solve for substitution because x is already isolated. But for the sake of solving by elimination, we're going to have to get all of our variables on one side and all of our regular numbers on the other. Okay? So that means this one's good, this one is not good. I need to move something. What should I move? The 2y. So I need to add 2y. Go ahead, Bonnie. What was that? Okay. So I added 2y to both sides, and it equals negative 11, right? So I need to take this right here, now that I've got it in the right place, and I need to move it over here, and I'm going to stack them up. But in order to eliminate something, I need something that's going to be the same but opposite. Okay? So what I mean by that is I need to have the same coefficient but an opposite sign. So it was nice, they start us out baby steps. The 2's are the same but opposite, right? So they will end up canceling, is the whole point of that. So negative 2y, positive 2y, they cancel out. I have no y's left. So this makes my life easier because when I add straight down, 3x and x make 4x's. 15 plus a negative 11 makes 4. I end up with an answer for one of my variables. So divide by 4, divide by 4. X then equals 1. Okay, any questions on that part? And then the easy part is once you get done with the first elimination, it just goes back to what we've been doing before. You just substitute x back in. So we have 1 plus 2y equals negative 11. And we just start solving. So subtract 1 on both sides. That 1 goes away. I have 2y equals negative 12. Solve for my y by dividing by 2. And y equals negative 6. And to write my final answer, because these are only individual solutions, I have to write this in coordinate form. 1 comma negative 6. Easy enough? Okay. Not all of your examples will be quite that easy. Some of these will have to multiply to make them the same but opposite. Okay, just going over how to check this real quick. If you want to check it, you just take one of your original equations, you plug in your x, you plug in your y, and then you solve it. So 1 times 3 is 3, and then negative 2 times negative 6 is a positive 12, and then 3 plus 12 will give us 15. So if you want to check it really quick, you can type it in your calculator and pop out an answer and double check it, just to make sure you did everything correctly. So that was part A. Let's move on to part B. Okay, part B gives us, again, 2 equations. We have 2x plus 5y equals negative 34. And we have a negative 3x plus 2y equals a negative 44. Okay. Now I'm looking at these. They're already set up the way I need them. I have all of my variables on one side and all my regular numbers on the other. So that's nice. Now what I have to start considering is how can I make, can I make these equations the same but opposite? And which variable should I get rid of? So start off, I want to decide which variable I want to get rid of. Which one would be easy to get rid of first? So I'm going to look at both of these. I have a positive 2 and a negative 3. I have a positive 5 and a negative 2. This one here? Oh, I'm sorry. Right, that's a positive 2. So we have positive, positive, and a negative and a positive. So since these ones are already opposite, they're opposite signs, I'm going to go ahead and use those. Now, what I have to decide, this is a lot like finding the greatest common denominator, okay? I need to find out what my my least common multiple would be for 3 and 2. And it's going to be 6, right? So how can I change this 2 to a 6? I do what? Multiply it by 3. But in order to make it all the same, I have to multiply the entire thing by 3. So now I have 6x plus 15y, and it equals, what is negative 34 times 3? I think it's 102. Okay, good, negative 102. Now over here, how do I change this 3 to a 6? Multiply it by 2. So I get a negative 6x plus 4y equals a negative 88. Okay, now I have opposite but the same, right? So I can just stack them. So negative 6x plus 4y equals negative 88. Okay. Now, I have people that end up forgetting what they're doing, so I teach this so that we don't forget where our equal sign goes. Equals plus equals equals equals. So that's very hard to say. Equals plus equals equals equals, to remind you that we're always adding. Okay? Equals plus equals equals equals. There's a lot of equals in there. So I'm just going to add straight down. Same sign, sum right there, so I'm going to get negative 190 on the right side of my equal sign. Over here I get 19y, and that eliminates. If for some reason you're doing a problem and it doesn't eliminate, chances are you forgot a step. So go back, figure out how to make something opposite but the same. Now I just need to finish solving. Divide by 19, divide by 19. Y is equal to negative 10. Okay? And again, I'm working in 2 columns, so I'm going to plug this one in over here. I'm going to plug it into my original equation so that I work with smaller numbers. Okay? So I have negative 3x plus a 2 times negative 10 equals negative 44. Start solving this one. 2 times negative 10 is negative 20. So I have negative 3x minus, because those are different signs, the negative wins out. And I have to add 20 to both sides. Finishing this out, I get negative 24 and negative 3x over here. So finish solving this, I divide it by a negative 3. Divide it by a negative 3. X equals then, negative and negative, we get a positive. It is 8. Okay. 8 comma negative 10. And again, if I want to check this, I don't check over here. I always bounce back and forth. Okay, so I want to check on this guy right here. So it's 2 times 8, which is 16, plus 5 times negative 10, which is negative 50. And I should get negative 34, and that's correct. Checks out. Okay. Again, you can just type that in your calculator rather quickly and call it good. Any questions? All right. Example 2. We're going to start seeing fractions, and we can make our life easier in fractions. Instead of dealing with fractions, we can make them to where they're whole numbers. So in order to do that, we just have to multiply the whole thing through by a certain number depending on what the problem is. So first problem, 3/4 x equals 3y, and then the next one is 15 plus 7y equals 3x. Now to solve by elimination, I need to get my variables on one side and my regular numbers on the other. So she says subtract 7y. That's correct. Minus 7y on both sides. I'm left with 15 equals 3x minus 7y. Why would I not want to move my 3x? Right, I don't want to do more steps because that would make my life a little more difficult. Also, it puts my 7y right where it needs to be, so that's kind of nice. Over here, which side do I want to subtract from? Because I have to have my variables on one side, right? I would want to subtract 3y. Because I'm putting my x up front, so I like to have my leading coefficient to be positive. So I would put it up front. If you did happen to move it to the other side, it wouldn't make a difference. Okay? Equals, what's 3y minus 3y? 0, right? Nothing is there. So now I have two equations. The problem is I don't see something fairly obvious that I can make opposite but the same, right? I do know this. I have a -3, a -7, a +3, and a +3/4. So I'm going to have to multiply something by a negative. Say that again. I could multiply by its reciprocal, but that'll end up giving me 12/3. Hey, that actually worked. We could multiply by its reciprocal in this case. But what I like to teach you guys so that you can see a way to do it every single time is look at your denominator. If your denominator is common, we're going to multiply it by its least common denominator. So if there's more than one fraction, say there's 3/4 and 1/2 here, we wouldn't want to multiply it by 2, we'd want to multiply it by the 4, because our least common denominator makes our problem easier. So if I want to multiply this one through, I'll multiply the whole thing by 4, and then I'm going to get in a smaller answer, hopefully. I'm going to multiply it through by -4 because I need to make one of these opposite. So I'm going to multiply it by -4. So what I'm going to end up with, -4 and 4 will cancel each other out on this little bit, and I will end up with a -3x. Then I have to give my -4 to that guy as well, so it gets a +12y. Is there any confusion on that part? I also distribute it to the 0, but anything times 0 is 0, so it doesn't matter. Any questions on that? Okay. Now I have this equation and I have this equation. It worked out nicely when I multiplied this by 4 because look what I have. I have a +3 and a -3. So I'm going to take this guy, I'm going to put him right there. Is it confusing anybody that I keep flip-flopping and putting my 0 and stuff on the other sides? No? Okay. Equals plus equals equals equals. Now I start adding straight down. So 15 and 0 make 15. 3x and -3x go away. -7, +12 make it 5y. Divide it by 5. Y then will equal just 3. And I can plug this back in on this side. Now I do realize that it is a little more difficult to plug this 3 in for the y and solve because of that fraction. But if you feel comfortable doing that, you're safer plugging it in up here just in case you made an error somewhere else. Okay? But if you're not, you should still get the same answer if you plug it in right here. So -3x plus 12 times 3 equals 0. So 12 times 3 is 36. And in order to isolate that, I have to subtract 36 from both sides. See how plugging it into the original would have been less steps. So I get a -36 on my right, and I have a -3 on my left, 3x. So I divide it by -3, divide it by -3. That cancels. I'm left with x. These two negatives will make it a positive, and it'll be a +12. Final answer, 12, 3. That is the point of intersection. And again, if you want to check it, you plug it back into your original problem up top, and you should be good to go. Okay? So 7 times 3 will give me 21 here. 21 and 15 make 36, and 3 times 12 was 36. So it worked out. No questions thus far? All right. These examples are kind of long. They take up big pieces. That's why we're only doing the lesson practice. Okay, on B, and I'm going to write a little bit smaller on this one just to save myself some room. I have 5/6 x plus 7/8 y equals 25. Now, if I don't want to deal with fractions, I can always multiply that through right off the bat. Okay. X over 3 is the same as 1/3 x, right? And then I have 2y added to that equals 76. All right, over here, in order to make this less fractiony, I want to multiply it by its least common denominator. What is my least common denominator of 6 and 8? Start thinking of multiples of 6 and 8. 6, 12, 18, 24, 30, 36, 48. We seen any? 24 is the smallest one. So I'm going to go with 24. Okay, 24 times 5/6. You can type that in your calculator if you'd like. Anyways, it'll spit out an answer of, I do believe, 20. Yes, 20. 20x plus, and then 7/8 times 24 should give us 21y. And then 24 times 25 gives us a rather large number of 600, I think. Now, I'm good there. I need to start dealing with this guy right here. What should I multiply him by to get rid of this 1/3? 3. Yeah, there's only one fraction, so that makes our life easy. And 3 times 1/3 gives us just an x. I like this number, and you'll understand here in a second, plus 6y equals 76 times 3, which is, say that again, 228. Okay, so why would I like a 1 coefficient? It's just easy to work with. I don't really got to think about anything. Anything can be multiplied and change this x to a -20 to really fast. Or I can change this x to a 75. I can change it to any number. It's really simple. Okay, so what would I want to multiply this one by now to make it opposite but the same? -20, right? The whole thing by -20. And I don't like how big these numbers are getting, but we don't really got much of a choice in this case. We get -20x plus, or no, I guess that turns into a negative. So minus 120y equals negative, somebody give me that answer, 0.654, 4,560, is that right? It was a big guess for me. Okay, so now I got opposite but the same, so I'm going to move it over here, -20x. And if you want to multiply this and write it down at the same time, you are more than welcome to do that. As we get comfortable in this, that's what I'll be doing. Minus 120y equals -4,560. And I start adding straight down. Equals plus equals equals equals. And I have a -120 and a +21 makes 99y. And then 600 minus 4,560 makes a number I'm not sure. So -3,960. Good. Divide that by the 99. Oh, I forgot a negative here. Don't forget your negative. And you said it's 40. So y equals a +40. And again, just plug that back in to one of your original equations if you want, or you can plug it into your converted one. I'm going to plug it into the converted one because it's a really easy number. 6 times 40 is 240 equals 228. Subtract 240. X then will equal a negative number, which is 12. -12. So final answer, -12, comma 40. In parentheses. There we go. Any questions? Megan, are you getting this? Okay. Come in the middle, it kind of makes it hard. Alright, last one that you'll see, we're going to do this on a calculator, so you should have it on a calculator as well as be able to solve these in longhand form. So grab your calculator if you don't already have it. We're going to convert some of these and check our answers on a calculator. First equation, 2x minus y equals 3, and then -6x plus 3y equals -9. Okay, I need to decide which variable I want to get rid of. I'm looking at this, I see that I have a positive and a negative, and then I have a negative and a positive. So either one will be easy. I just have to find a common multiple to go to. So let's get rid of x. How am I going to change 2? What is the common multiple, I guess? 3. So we're going to multiply this thing. It's 6, right, total? But we're multiplying by 3. So I understood what you meant. All right, so 6x minus 3y equals 9, right? So 6x minus 3y equals 9. And equals plus equals equals equals. And I go straight down here. So those cancel. Well, those ended up canceling as well. So I have 0 on this side now. I have -19 plus 9, which gives me a -10. Now, is this answer something that's true? No, it's a... Did I copy it down now? Oh. Alright, well, let's play this out the way I wrote it, since we already did that way. I get something that's not true, right? So, since it's false, how many solutions do you think there are? No solutions, right? So, if we get something that's false, and you get no solutions, your graph will tend to look like this. They're parallel, right? So if we solved each of these for y equals whatever, then we'll get that solution in our calculator as y equals. If you tried to do second calc and find an intersection, there would be no intersection. Okay? It'll probably give you a syntax error. If you end up getting something that's true, so for example, if this was a negative 9, instead of a 19, then we would get 0 equals 0, and 0 equals 0 is true, infinitely many solutions, and that would be correct. Now when you try to graph those on a calculator, you're just going to get, if you get something that ends up being 0 equals 0. So say we had the negative 6x plus 3y equals negative 9, okay, like I was supposed to write down. And then we subtract all of this business from it, and we end up with that 0 equals 0. Your graph then will look like this. It'll just be one solid line, one right on top of the other. Okay? You won't be able to see two different lines. It'll just be one. Okay? So if we solve this in our calculator, you would have to isolate them down to y. So we'd have to take 2x minus y equals 3 and solve it for y. So I'd subtract 2x. And then I'd have to multiply the whole thing through by a negative to get rid of that negative 1. So I have negative y equals 3 minus 2x. Multiply the whole thing through by a negative, and I get y equals negative 3 plus 2x. And I can type that into my calculator. You can do the same thing to the other one. You'll get the exact same equation. Okay? Any questions on that stuff? Do y'all feel like we need to do another example? Okay. And you have everything you need.